right? I'm really just completely focused on this side, but I want to see what happens when I divide in, and if it goes in evenly or if I have a remainder left, right? Is that making sense? But what did I do here? What are you noticing? What the hell is this? Exactly. It's X squared term, but there's none of them. So I'm putting in, I gotta make sure I have a placeholder for like $1,000, hundreds of dollars, tens of dollars, ones of dollars, right? I'm putting in a placeholder for anything that's missing in between my leading term and the end term. In fact, if I had no constant, right, if I had no minus 8 at the end, I would want to put in plus 0 as well. First thing make sense at all? We're doing long division. So the whole thought is, and I'm recording, okay? The whole thought is, like when we decided to do 42 into 279, I would just think about 40. You know what I'm saying? I would just think about how many times does 40 go in, right? It goes in 6 times, right? Because 6 times 40 is that 240 plus another 12. You see it? So same thing here. I'm saying, well, how many times does x go into x cubed? Or better yet, x times what is x cubed? What's the answer? Yeah, x squared. Now what would I do with the 6? Look what I did with the 6. I came and multiplied by the 40 and multiplied by the 2. So I'm doing the same thing here. I'm going to multiply this x squared by the x and by the negative 2. And I get x cubed minus 2x squared. Yes, you with me? Has anybody done this before? Long divide polynomials? Nice. I now change my signs and add. I change my signs and add, just like I did in 3rd grade, right? I change the signs and add. What happens to this first term every single time it goes away? Goes away every time. And when we learn synthetic, you'll see how we rig it so we don't have to bother doing things that just go away every time. And now I rinse and repeat. So I change my signs and add. So that's gone, and I have a 2x squared plus 0x minus 8. Now I start over again. Same process. Exactly. X times what will get me to 2x squared? Nice. Come back and multiply to everything, right? 2x times that, 2x times that. I get 2x squared minus 4x. Change my signs and add. The first term will go away every time. Is this okay? We're okay here? Yeah, so change my signs and add. So I get 4x minus 8. Rinse and repeat. This is why I don't buy hair conditioner. It says on the bottle, rinse and repeat. It doesn't say how many times. So every time I buy it, I run out the first time. Plus what? X goes into 4x how many times? 4. Come back and multiply. 4x minus 8. Change my signs and add. I get a remainder of 0. Yep, x goes into 4x how many times? 4 times. Come back and multiply. Change your signs and add. So look at what it says. It says x cubed minus 8 over x minus 2 is x squared plus 2x plus 4 plus a remainder of 0. It doesn't make sense at all for me to put the remainder of 0 there, right? But what's the key here? What's the key here? This thing does what? We're just trying to do it with a quadratic. What does that particular function in the numerator do? Back. So what we really like to see, especially in calculus, is we have x cubed minus 8 over x minus 2. Guess what? X minus 2 goes into x. So what I'm sorry, I'll do it this way. F of x over g of x equals q of x plus the remainder over g of x. And what I'm going to do is multiply everything by g of x. So I've got in black the original f of x over g of x equals q of x plus the remainder over g of x. And then I'm multiplying everything by g of x. And look what I get. F of x equals q of x times g of x plus r of x. So this is the one I want to double check with, right? And what did I have? I had x cubed minus 8 here. Then I had, don't tell me, x squared plus 2x plus 4 times x minus 2 plus 0, right? So forget the plus 0. So tell me now, what did I just do with x cubed minus 8? What did I do with x cubed minus 8? That's with Tom Cruise or Sidney Poitier. This was an F and with Nicole Kidman. Viola Davis. It was an F and with an actor. Factor. That's what we're doing. We're long dividing to find factor. So I'm gonna do a heck of a lot more. So let's do another one from a section of the book where I'm gonna get a remainder. Yes, question, Brian. Yes. Yeah, the long division piece will take some practice. You go home, you search on YouTube for it. There's 10,000 nerds. Find the one that clicks for you. Like, I like Khan Academy, but he puts me to sleep. So you've got to find someone who's going to really make it work for you and make yourself understand it. I'm going to do a bunch more. Okay? Here we go. This is section 4.2. And I want to take a look at just this first particular example. So it's real simple. I think it's example 1. It's okay. So find r of x over g of x, right? If f of x, which is x cubed minus 4x squared minus 5, is divided by x minus 3. Yeah, maybe I'm just finding my remainder. Let's do it that way. So what are we going to do? We're going to look at that same thing, right? We're looking at x cubed minus 4x squared minus 5 divided by x minus 3. That's the problem. And if you can kind of see it, I'm asking, will this thing divide in evenly to this function or not? That's what I'm interested in when I'm factoring. Nice. So I got to set up my long division again. I'm going to go x minus 3 into x cubed. Do I have an x squared term? Yes. Minus 4x squared. Do I have an x term? No. 0x. Do I have a constant? Yes. Minus 5. I'm asking, does x times what goes into x cubed? Nice. X squared. Come back and multiply. Multiply, right? So I get x cubed minus 3x squared. Change my signs and add. Everybody following? Change the signs and add. So the first terms cancel every time. I get negative x squared plus 0x minus 5. How are we doing? Yes, so when we did this 4 into 21, right, we said 5, then 5 times 4 is 20, and then we subtract, right? You remember doing that? So right there, after I multiplied back, I changed the signs and add. Question, CD? No? You're okay.
So I'll get that when you got the x squared, right?
Yep.
And therefore you just multiply, I guess, negative 3 times x squared.
Yep. And I got the green.
And then you just brought it down.
And then changed my signs and then added.
Okay, and that's going to give you 1 x squared.
Yes, minus 1x squared, right? Rinse and repeat. X goes into negative x squared by what? Negative x, right? X, so negative times positive is negative, x times x is x squared. Come back and multiply, and I get negative x squared plus 3x. Change the signs and add. Change the signs and add. So the first terms go away every time. So I get minus 3x minus 5. Rinse and repeat. Yes, you with me? You're starting to get it a little bit? So it looks like I need a negative 3. Come back and multiply. Change the signs and add. I get a remainder of negative 14. Three times 3. Yeah.
Oh.
Right? 3 times negative 3 times x, negative 3 times negative 3. That's a positive 9, but then I changed my signs and added.
Oh, okay.
Nice. I want to double check this. Okay? Well, the first way I check it is I look in the back of the book. I look at the answers. Right? I want to do that most of the time, but every now and then I want to check either using Desmos or check algebraically. So how do we check this algebraically? We're going to say my original numerator is equal to my quotient times the divisor plus the remainder. This is my check. Right? It's f of x equals q of x times g of x plus r of x. I'm only working on which side now? For my check, I'm only working on the right side. You see it? So it's kind of like FOIL, but more than 2 terms, right? More than 2 by 2. I got an x cubed. I get a minus 3x squared. I get a minus x squared. I get a minus 3x. I get another minus 3x. And I get a positive 9. And then a minus 14. Notice that each time I multiplied, I created a new row. And you can kind of see that I'm recreating the long division process again, but in reverse. So what do I get? X cubed minus 4x squared. Oh, I made a mistake here. Oh, there's a positive 3x here. Minus 5. There it is. I made a mistake here for minus x times negative 3. That's a positive 3x. How are we doing? Yep. Exactly. Yeah. It's yeah, it's weird. Well, wait till you see synthetic. If um, long division is better than synthetic division, but synthetic division is so elegant. My issue is I can take any two polynomials and long divide them. I can't do the same with synthetic, and you'll see in a second, okay? I want to do those same two problems with synthetic division, okay? I want to do the same two problems I just did with synthetic division. Question?
The same thing, just different ways of doing it.
Yes. Yeah, so if you look here, I only have an x to the third, right? Here I have minus, right, negative 3 and minus 1, that's negative 4x squared. These cancel. Right, you see it? And so I was doing this too, and you're going to see me do more. So I'm saying, okay, my first row is going to come from me multiplying to here and to here. So there's my x cubed minus 3x squared. My next row is going to come from here and here. There's my minus x squared, my plus 3x. The next row is coming from here and here. Yeah, okay. You got it though, right? Yep. So what was my first problem? I want to talk quickly about the remainder theorem, and then I want to do synthetic division. Okay. So is this okay if I'm going? Are you copying? What do you need? We're okay. Okay. So my very first problem, I had f of x equals x cubed minus 8, right? And I said divide by g of x, which was x minus 2. What makes this 0? What number makes this 0? Actually, what number makes it 0? Plus 2, yes. I want to look at what I get from f of 2. That's 2 cubed minus 8. That's 8 minus 8. That's 0. The remainder, when I plug in a 0, and I get a remainder of 0. Sorry, when I plug in a number, I get a remainder of 0. I know its factors. What was my second one? F of x was x cubed minus 4x squared minus 5, right? And I had g of x. Is that right? Yeah. And I had a g of x minus 3. So watch what happens when I plug 3 into f. Anybody know the answer yet? All right, here we go. 3 cubed minus 4 times 3 squared minus 5. That's 9 minus 4 times 9 minus 5. That's 36. Sorry, 36 minus 5. Wait a minute, I screwed up somewhere. Sorry, 1 second. X cubed minus 4. Oh, x cubed is not 9, it's 27. 3 cubed is not 9, it's 27. Sorry. Right, so what do I get? I get negative 14. What is negative 14 from the problem I just did? It's the remainder. So I can evaluate a function at a point and get the remainder from long division. That's crazy. That's crazy. All right, same two problems, synthetic division. We ready? Yep, I'll wait.
try synthetic division over.
I always try synthetic division if what I'm dividing by is linear. If what I'm dividing by is mx plus b, I'm always going to do synthetic division. Okay, we good? Chris, yeah? Yeah, thanks. So synthetic division, here we go. Put the seatbelts on. I'm doing 8 cubed, x cubed minus 8 over x minus 2. I already know the answer is 0. I know the remainder is 0 because I did it already with long division. But I'm going to set up my synthetic division. I do an upside down long division symbol. I'm putting my 0 out front. Again, what's the question? What x makes x minus 2 0? 2. I'm putting in just my coefficients of x cubed, x squared, x, and my constant. Since I put them in placeholders already, I already know it starts with x cubed, it goes to x squared, it goes to x, it goes to a constant. And I bring down my initial value because I know it has to go in. I know x goes into x cubed, right? So a couple little notes, right? What makes x minus 2 equal to 0, right? What about here? Coefficients from my numerator, right?
So you got the one with the x squared?
Yes. Yeah. It'll make more sense in 1 second. Coefficient from x cubed minus 8, right? And so I'm saying, just always, you're going to bring this first one down every time. And you're going to see why in a second. Now, instead of changing signs and adding, we're going to just add. Because I picked the opposite here, it's already changing signs already for me. Okay, so 2 times 1 is 2, and now add 2. Rinse and repeat. 2 times 2, yep, so 2 times 2 is 4. Add 0 and 4 is 4. 2 times 8 is 8. Add. Say again? One more time. No, 2 times 4. Now, look, I started with x cubed, but I divided by x, so where does this one have to start? The 1 is the coefficient of the x cubed. Okay, but if I divided x cubed by x, where does it have to start? X squared. So this is x squared plus 2x plus 4. That's the same one I got before with a remainder of 0. This is 1x squared plus 2x, yes, plus 4. Let's do the other one, okay? Same problem. We did 2 problems already, once with a remainder of 0, once with a remainder of negative 17. So let's see what happens when I do the one with negative 17, right? So again, my problem is x cubed, right? It's this one, right? So I'm looking at f of x equals x cubed minus 4x minus 4x squared minus 5 over g of x, which is x minus 3. And I want to do this with synthetic division. So I want to start with 3 because that's what makes that denominator 0. Everybody with me? I need the coefficients of x cubed minus 4x squared plus 0x minus 5. I need a 1, a negative 4, a 0, a negative 5. Right? Does everyone see where that's coming from? Those are my coefficients. Notice I don't care about the x's anymore. This for computer scientists is ideal. We don't care about the variables in computer science. So imagine ripping away x, y, z, a, b, c, and all you have are the coefficients. It's so much quicker, right? So computer science and linear algebra, this is a piece of linear algebra. I'm going to bring the first one down. Why? 1, because Robert said so. But if you notice, when we're doing the long division, that first thing had to go into the, right? That first x had to go into whatever I was dividing into. Now I'm going to multiply. What do I get? And add. What do I get? Minus 1, right? Rinse and repeat. Multiply. What do I get? And add negative 3. Right? 0 plus, minus 3 is negative 3. Multiply. Nope. Negative 9, add negative 14. There's my remainder again.
So if it's not an MX plus B format,
You can't do synthetic. If I ask you to do synthetic, it'll be a problem that you can do synthetic with. If I ask you to do long division, it could be done by synthetic, but most likely, right, I just want you to have both methods. All right, now I gave you a bunch of suggested problems in 4.2. The first set of problems in 4.2 is that long division process or synthetic division process. There's a lot of other theory in here, but I just want you to focus on the ones that I'm doing with you. Sorry. So that first set of problems is 43 to 55. Wait a minute. Sorry, 11 to 19. So they're giving you a polynomial. They're giving you something to divide by, and they want you to find, right? They want you to find whether there's a remainder or not. If there's no remainder, what does it mean? It can be factored. If there's a remainder, it can't be factored. Which one did I give you to do here? I gave you 19. Let's do 17. And I'm going to write it right now. If you're not quick enough for me, I'm going to write it right now. This is 4.2, number 17. You're doing 19 for me for homework. So I've got my f of x is 4x to the 6th minus 64x to the 4th plus x squared minus 15, and my g of x, what I'm dividing into, is x plus 4. What do you want to do? Long division or synthetic? Which one? Long, and let's do them both. Doesn't matter. So let's go x plus 4, long divide into 4x to the 6th plus 0x to the 5th minus 64x to the 4th plus 0x cubed plus x squared plus 0x minus 15. Math to me is like jail. You can sit there and be miserable, or you can get something out of it. Read a book, exercise, right? So you have to do this. So Make it a game. Make it fun. So what are we're gonna ask first? Yes, 4x to the fifth, right? And you kind of see that when I have an x to the fifth term, I'm trying to keep it in its column, just to be a little bit extra neat about it. I'm going to come back and multiply, right, plus 16x to the fifth. And do you see why I bring down that first one? Because the first term crosses out every single time. I am not left with an x to the sixth factor anymore. I'm going right to my x to the fifth. When I'm doing synthetic, right? Remember that first one crosses out? Go ahead, CD.
Where did you get the 16?
Yeah, so come back and multiply, right?
So 4 times x is 4x.
4 times, 4 times x to the fifth is 4x to the sixth, sorry, 6. Yeah, but they cancel, right? I change my signs and add. So what do I get now? Negative 16x to the fifth. Trying not to make a mistake. It's not easy, right? But hopefully you make your mistakes when you're practicing. And rinse and repeat, yes? Right. So I don't need the zero. I don't need a zero lead. Yeah, 16 times 4 is negative 64. Yeah. Get a remainder of 1. Anybody else get there? We okay?
So once you get the x squared plus 0x plus 15, right?
Yeah.
Then it'd be x. The x cancels out. You're left with negative 4x equals 15.
Yep, but bring all the other pieces just straight down. Don't change their sign. Right, this one came straight down, this one came straight, right? They don't change signs when you do that, right?
Okay. So I'm at the point which is negative 4x plus take away 5, right? So wouldn't you add 4 cancel out the 4x or no?
Wait a minute. Can you give me what line you're on?
I'm probably on line 6.
Okay, so this is the problem, but I'm saying x goes into x squared how many times? X times.
Yeah.
Come back and multiply x squared plus 4x. Change the signs. The first one cancels, so I get minus 4x minus 15. Yep, and I'd rather, and it's good to see this, I'd rather you be thinking with paper and pencil. If you're just looking at it and trying to get it, it's not going to work out. I don't know about you, but inside of my head, there's a lot of other shit going on. So when I can put something on the paper, it makes it so much simpler. I'm not thinking about driving home in the rain when I'm just writing, 4 times something kind of thing. Jose, you wanted that long division, am I right? And did you get it at all? Did you? Brian, what were you going to say? Yep.
And I was negative 4x squared. So I multiplied it by 4x. And instead of getting 1, I get negative 15 plus 16x.
Okay, but so you got the negative 4 here, correct?
Mm-hmm. I did
Brian?
4x.
Okay, but x goes into negative 4x just with negative 4. Right? I'm asking, x goes into negative 4x with negative 4. And then I come back and multiply. Let's do it with synthetic. You'll see how much easier it is, please. Can we do it with synthetic? Let me do it with synthetics. CD, you're going to have to write it over. Don't look at it and do it. Write it. Okay. What do I put on the outside of my synthetic? What makes this 0? Negative 4. I'm starting my synthetic with the opposite sign so I don't have to change signs and add. All I have to do is add. My coefficients are the same. 4, 0, negative 64, 0, 1, 0, negative 15. I'm using just the coefficients from x to the 6th all the way down to the constant. Are you with me? I'm going to automatically bring down whatever this is, and it's a 4. And now what? Do what with these? Multiply. And now what with these? Add. Again, multiply. That's positive 64. And add. I get 0. Yes, you with me? Multiply. I get 0. Add 0. I multiply. I get negative 4. I get 0. Thank you. I add, I get 1. I multiply. I add, I get negative 4. I multiply, I get 16. I add, I get 1. That's my remainder. How we doing? I think we need a little break, so let's take a little break. Yeah, 4, where are you at? Oh, right here, negative 4 times negative 4 is positive 16. The issue with synthetic is I have to make sure I'm dividing by something like mx plus b. I have to divide by something like mx plus b in order to do synthetic. I cannot divide by x squared using synthetic. But once again, I'm not going to try and trick you with something stupid like that. I'm going to say do long division here, or I'm going to say do synthetic division here. All right, let's come back to 325. Okay, 5 minutes.
All right. I understand what you did right there.
Yep.
Go through it.
Yep.
My only thing I don't understand is how do you know where to put the numbers when you're doing the long division?
Yes, so I'll try to one. So I start from the left, right? From all the, and I'm asking, okay, x to the 4x to the 6, to the 4x to the 5th, and now I'm lining it up. No, I'll say the okay. I did this. Yeah. Well, that's why is 4x to 6? No, it's 4x to 6. Yeah, what is no x? Because there's no x to 6 term. I have to have placeholders, like $100 bill placeholder, $10 bill placeholder, $1 bill placeholder. Makes sense?
So for example, this is like, instead of 1 to the power of 6 to the power of 7.
Exactly.
would have to place it. Oh, okay.
Just like when we were learning how to add money, we had that, we put things in column, right?
Yeah, that was the main part of it. I'm gonna try it.
So, let me see.
So I know that like the
So this one it's not even there. It's a zero, so we don't even need it. That's where you got screwed up.
Oh, okay.
Because if you said x into 0x cubed, it's still 0,
Yeah.
right? So you would have a 0 x cubed up here.
Okay.
So, and you said x squared, that was the problem.
And that's why I got this
Exactly,
instead of, okay.
exactly. So what you want to actually get back to is get rid of these two,
Okay.
right? And then start over here, but notice you're going to have the x squared plus the 0x, you're missing your 0x term. Right? Does that make sense?
Yeah.
So when you bring one down and it's a 0, ignore it. Don't even bother going long division into it.
All right.
Right? It's weird.
So for example,
Yeah.
what I need, for example, number 15,
Yeah.
would I need 2 placeholders? Like 0.
You got a third, you need a square. You got everything else. You got a fourth power, you got a third power, you don't have a second power.
So we need the second power.
Yes, 0x squared.
So it'd be 0x squared
Minus,
plus 5.
yeah, what is the 5?
Plus?
Minus 5x. Yeah, plus 0x squared.
Okay. Okay.
Right, right?
Yeah. That makes a lot of sense.
Yeah, it's just like when we were learning how to balance a checkbook or whatever. We had those things all lined up.
That's a different problem. I'm looking at number 15. You looking at number 15. I was looking at number 15. 3 to the power of 6. So
You need a fifth and a fourth.
okay, so it'd be 0, 0.
And then,
to the power of-
yeah.
Okay. That makes a lot of sense.
Again, stop doing it, work in your head. Do it on-
Oh, that's what I'm about to do now.
But it doesn't work for everything. It's when they start to go away. Right? And we have to placeholder for X and function. So to get it from the one number of what so by going like X squared, dividing by X squared. So what's the one thing that makes you feel? So that's why I want the linear. Divided by linear. And that's what you do. Like no X cubed, no X squared, no X equals.
So this is what it would look like.
Exactly, and you need plus, two plus, and a plus. There's your X cubed, you need an X squared and an X.
Oh, yeah, for X squared.
Yeah, and X. So plus 0x squared plus 0x plus 27. And put the signs in there so you don't lose that kind of column separation.
Plus 0, X squared. Yeah, plus 0, X squared.
Yeah.
And then for synthetic, I'm using the same exact numbers I used for the long division.
Exactly. But that outside number will change from an x plus 4 to a minus 4.
So even though the upper
All right, good. Let's get back here. The next set of problems I want you to do is in number 51. And so they teach something. You ever hear René Descartes? I think, therefore I am. He was a French philosopher, also a mathematician. The Cartesian plane is from René Descartes, XY axis. So he worked a lot on all this synthetic division stuff. But we're not going to use his theorem. We're going to use a graph. So looking at number 51 here. This section's a little intense, okay? So I probably will work on it more on Wednesday, okay? So don't stress about it. Just practice. So I want to look at number 51, and it says, find me real zeros and factor. Okay, so this is a brand new thing. So we're saying we're going to factor a polynomial. Right? So I'll show you the process I want you to do. And this is what I want you to do when you're trying to find zeros in Calc 1. I want you to use this process in Calc 1. Okay? We're going to be finding zeros all the time in Calc 1. So here's we're saying factor a polynomial. And this is 4.2, number 51. So everything in this section, I think it's 51 up to 67, you're going to do the same way. So first of all, we're going to look at f of x. It's x cubed plus 2x squared minus 5x minus 6. And I'm going to see if I can find a 0. And I'm going to do that by looking at the graph. Here we go. Desmos. Every class will be doing Desmos, so I want you ready to work on it. So I have x cubed plus 2x squared minus 5x minus 6. And then I'm asking you, can you see a 0? Yeah, 2. What else would work? Negative 3, negative 1. I'm going to go with 2. I don't want to deal with the negatives. So what I'm going to do is I'm going to whittle down the polynomial down to somewhere I can factor without synthetic or keep going with synthetic. And every time I take a factor out, it's going to be called a depressed equation. It's funny because whenever I go to the doctor, my tongue gets depressed. It's a joke. So, thank you. So I'm going to start this problem with synthetic and 2. I saw 2 worked as a 0. You with me? So I got 1x cubed, 2x squared, minus 5x, minus 6. Synthetic, yes? Don't let me run you over here. So I saw 2 was a 0, right? So what's that telling me? If I put 2 into this function, I'm going to get a remainder of 0. But the other pieces are going to give me the factor, okay? So how do I start? I bring down the 1. Whatever's here, I bring it down, right? Good. 2 times 1 is 2. Add 2 is 4. 2 times 4 is 8. Add, I get 3 if I add, right? And then 2 times 3 is 6, and I add and I get my 0. Listen to this, and this is how I want it written. Since x equals 2 is a 0, x minus 2 is a factor. Every time we're going to do this. Since x equals 2 is a 0, notice that you see my 2 moved to the other side, became opposite, right? X minus 2 is now a factor. So is, since x equals 2 is a 0, we say x minus 2 is a factor. So is the depressed equation of x squared plus 4x plus 3. You see where I got that from? When I get a 0, I get a factor. And then what my quotient for that is we're calling the depressed equation is also a factor. So look at what I have now. Is everybody okay? Strange language, but you're going to put it on your formula sheet. So is the depressed equation. So look what I have now. X cubed plus 2x squared minus 5x minus 6 is now x minus 2 times x squared plus 4x plus 3. Make sure you're with me here.
So, let's say for an exam, you want us to write what's in the green and not the blue.
Yeah, I'm gonna say to you, factor this polynomial form. And the first thing you're gonna do is graph it, find the 0 on the graph, right? Synthetic divide, whittle it down. At this point, we can usually factor a quadratic without doing anything. Anybody see the factors already? What factors? Add, multiply to 3 and add to 4. X plus 1 and x plus 3. So at this point, we could go back to synthetic, but we don't have to. We know how to factor quadratics. Done. Why are we doing this? Well, for right now, remember, we want to graph this, right? But we don't know if it has repeated zeros or not, etc. We can graph it, look, but it still doesn't help us get down to this. So we saw that 2 is a 0, we synthetic divided, we got this as our quotient. The product of them is still our original. But then, once I get to a quadratic, I usually get factored. And we'll say, if I have a quadratic that doesn't factor, we're stopping there. We're not doing the next section of the book, which is complex zeros. So if we get to a quadratic and we can't factor it, stop. We're not. I cut them out completely because they're not in calculus. I'm trying to make pre-cal into pre-cal 1. Originally, pre-calculus had topics for calc 1, calc 2, and calc 3. So I've stripped out all of the calc 2 and calc 3 just because I failed 75% of the students every semester. So I'm trying to just rip that stuff out. You don't have to think about it until you get into calc 2. Can't see because I was standing in the way. Sorry. Make this fun. Make it fun. You ever play a game with a niece and nephew or younger brother or sister, and you're miserable and they just hate you? You got to make it fun. If I play Monopoly, I'm the banker and I just steal money the whole time, right? So whatever you got to do to make it fun, make it fun. Let's do one more. Yes, ready? So in the textbook, yeah, I like let's do 65. I think 67 is the one I gave you. Yes, because we're going to try and factor this, right? So we got to see where a possible 0 is, a possible root. So I have f of x, 4x to the 4th plus 7x squared minus 2. And we're going to Desmos. Yes, you with me? So 4x to the 4th (7x squared). Thank you. Thank you. Uh-oh, I gotta have something wrong. Oh yeah. Now watch this. Yep, you're right. Watch this. Desmos is kind of sweet. I can just hover on the 0 and it tells me the x value. Right? So 1/2. Yeah? With me? All right, here we go. 1/2. Right? We agree? 1/2? So 1/2 is a 0. So I've got a 4, a 0, a 7, a 0, and a -2. Everybody there with me? I've got an x to the 4th term. I don't have an x cubed term. I got to put a placeholder there. I'm going to bring down that first coefficient, whatever it is, and then multiply. Half of 4. Add 2, right? 0 plus 2, right? We're doing 0 plus 2 is 2. Multiply. Half of 2. Add 8. Yes. Right? Half of 8, 4. 4 plus 0 is 4. Half of 4 is 2. I better get a 0 there. I have to get a 0 for my remainder. That's the whole theorem. If you get a 0 for your remainder, you found a factor. Since x equals 1/2 is a 0, x minus 1/2 is a factor. So is, remember I started with x to the 4th, 4x cubed plus 2x squared plus 8x plus 4. That depressed equation is also a factor. That whittled down, right? The one that I kind of chopped into, long divided into, synthetic, CD what?
So the difference between how we did earlier in this one is they don't give us the g of x.
Exactly. Yep. So now I know f of x, which is 4x to the 4th plus 7x squared minus 2, is x minus 1/2 times 4x cubed plus 2x squared plus 8x plus 4. Guess what? Rinse and repeat. Looking at my Desmos, I also see what's another 0. Negative 1/2. So I'm going to use my synthetic division with minus 1/2 and this depressed equation. Right? You see that? I'm getting these coefficients now from this depressed equation, from this other factor. How are we here? Okay. You can grunt or something, communicate somehow for me. I understand the negative grunt and the positive grunt. Right? That's no, you're not okay. That's you're okay, right? So now x equal minus 1/2 is a factor. Sorry, is a 0, right? So x plus 1/2, notice it moves to the other side, is a factor. And so is what? What's left? I started with 4x cubed this time, right? So what did it reduce to? 4x squared plus 8. So now f of x is x minus a half, x plus a half, and 4x squared plus 8. Anything else you see factor there? A 4, yes. No, this is test 2 stuff. You need some time to practice on this one. But you're okay though, right? Everybody, you're fine with it, yes? Just don't practice without paper. Make sure you're doing problems. Check with the book. Check every now and then with Desmos. Check every now and then doing algebra. Boiling it back out. I claim I'm done because this is some other function x squared. And I'm going to move it where? Up to. Right? That 2 is on the outside of this, right? So if I move it up 2, it doesn't factor. It doesn't hit the axis. Of course, I could graph this and make sure, right? But when I get to a non-factorable quadratic, done. Oh my God, what a headache, huh? Anybody else? Headache? I say around 20 minutes before 2, you take your 500 milligrams of Advil or something, you could be fine. Still could hit you every now and then. Oh, sorry. Can you move the keyboard?
So the reason why you did the negative one plus all that, is it just
Okay, so I saw on the graph, I hovered over on this one, I hovered over that point, and it told me x is negative 1/2.
Yeah.
So because that hits where the axis is, that's called a 0. So I start the synthetic divide with what I think is a 0. I got the remainder of 0, so I know it's true. So I know x equals minus 1/2 is a 0, because I got the remainder. So move it over, x plus 1/2 is a factor. You see how I move this 1/2 over to the other side to get plus 1/2? Yeah. Every time. Every time I'm doing that.
So what I'm saying is, if I'm going on an exam, right?
Yeah.
If we have 2 points, you have to.
Either one's fine to start.
Okay, so you just get both.
Yes. Usually when you have an x cubed function and you start with a bound 0, you'll get to a quadratic and then you can just factor. You don't have to do any more synthetic. The one I gave you for homework is x to the 5th. So most likely you're going to have to synthetic divide 3 times before you get to the quadratic. Right? Because x to the 5th could have 5 zeros. Yep. We use this in calculus all the time. I have students that skip pre-cal. They cheated on, oh, am I recording this? They took a shortcut on the placement test, and they're placed into calculus, and they can't do any of this stuff. And they're screwed. They're not going to make it. Right? And we tend to take shortcuts because we don't want to be here long. We want to get out and go to university. But if you take a shortcut that's so drastic, it actually will take you twice as long. Right? You skip pre-cal and then you failed it. And then you go back to pre-cal? Maybe you only have to go back further. Right? So I'm proud that you're all here. I know what it takes for you to be ready for calculus. Okay? You've got to practice, you've got to make mistakes, you've got to ask for help. All right. We want to do one difference quotient problem for like the quiz?
Yeah.
Okay. So the difference quotient problem that I'm giving you is going to be a fraction. Okay? So I want to do a difference quotient with a quadratic. Does that make sense? We did a difference quotient the very first homework. I gave you a difference quotient with a fraction. Okay? So I'm going to do one with with a radical. So I'll have f of x equal square root of 1 minus 2x. I'm going to ask for, I'm sorry, yeah, this is right. I'm going to ask for points on here at 0 and -4. What do I get when x is 0? What do you see it?
When x is 0, you get from 0 to
Almost. 1. When x is -4, what do I get? 3. Right? -2 times -4 is +8, plus 1 more is 9, square root of 9 is 3. I'm going to pick nice numbers for you. We already can find the slope of this secant line, but I want to see that my difference quotient gets it the same, right? So what's my slope right now of this secant line? -1/2, and it makes sense that it's negative, right? Because you can see the right. You can see the slope is negative, right? Am I right? All right, here we go. We're going to get our difference quotient, right? Which is the slope of our secant line is equal to the limit. Oh, I'm sorry, is equal to f of x evaluated where? X plus h minus the original function all divided by h. I'm going to do one more step and I'm going to let you go for a little bit. I just like to clear those parentheses if I can, and then go with my difference quotient. On your mark, set, go. Right? Don't copy me. Do your own work. Don't copy me. I just get bored, so I can't sit here and wait for you all to do it. Oh, you there already? Wait for me. We're using 1, 0, 1, and -4, 3. I know that's fast. Anybody get the difference quotient already? You know when we get the difference quotient. Just watch me do this stuff. In order to get in there, right? Get nice. Yeah, so I got, if I start, if I move left, H is negative. If I move right, H is positive. So I can either start on 0 and move left, or I can start on -4 and move right. So, right, so from -4 to 0, H is 4, move 4 to the right. So I can use these two in here to get the slope for these two. And I should get 1/2. Right? Exactly, exactly. I didn't bother distributing, so it really should be 1, right, parentheses 1, -1, parentheses 1, 2x. So this is either positive 2x, sorry, the negative 2x and the positive 2x. No, yeah, it was existing squared plus this is squared. That's why minus that. That's what you need to put it. And who got there? Speaking slow, different quotient. Anybody? What? You focus on it up there. Can you leave here and not do this problem over? No way. Right? You got to be able to do these problems. Because we're going to do them in calculus. We're going to do something even more elegant in calculus. We're going to let h go to 0. Which means my 2 points become 1 point. And then I have something called the derivative. All right. I like to work with h as positive, so I'm going to use this guy. I'm going to use this one. So everywhere there's an x, I'm plugging in a -4. Everywhere there's an h, I'm plugging in a +4. No, I just made it up. Looks like I screwed up something. Oh no, -1/2 is what I got, right? Yeah, I'm okay. Talk to me. What are we having trouble with? Talk to me, please. What are we having trouble with? I'm too distracted by my phone. I'm not writing anything down. I don't know what's going on. What is it? What's going on? Is it the conjugate? What is it? what's bothering you in the problem? I wanna know, how am I gonna be a better teacher if I can't?
For me, I'm on the third line.
Yeah.
I understand what you did.
With the green cross out?
You did like terms and one take into X.
Yeah.
It cancels out.
That's right.
But how did it end up in the bottom of the phone?
It didn't end up in the bottom. The bottom's from the conjugate. See the purple?
Yeah.
Purple over itself? That's one. When I distribute upstairs, the radicals cancel.
Okay.
And all I'm left with is the negative 2H.
Okay.
Chris?
You said for the last one,
Yeah.
for like another 100.
Yeah.
You said -2 over. Is that fair?
That's a 3. That's a 3. Square root of 9 is a 3.
Oh,
Sorry.
okay.
It's a Polish 3.
I was just a little confused.
Yeah. Polish 3. I'm just going too fast, but all I can think about is driving home in the rain and then eating dinner.
What's it doing?
I don't know. What day is it? Damn, I wish it was Tuesday.
I got pop
I got pizza beer and pizza Dillard in this.
So the cancel out, you're left with 2. The H's cancel out. You're left with -2.
So, you're gonna practice for Wednesday. You're gonna do the one on the quiz we just did. You're gonna do this one. You're gonna do the one in the textbook that I assigned for homework that I didn't teach you how to do, but I did it the very next class. And if I put that one on the quiz and you can't answer it, I know, so one of two things. You're not doing anything. I don't know what the other one is. I think the tricky part here is the X and the H. If I'm gonna pick X as the -4, to get to the next point, I have to move to the right. That's 4 to the right, that's H. If I pick X as 0, I have to move 4 to the left. That's H is -4. So one or two choices. I typically try and pick H to be positive. Just because I don't have to deal with the negative sign. We want 2 pictures here, maybe better zoom quality. There's the first. Anybody want the picture? So we're doing one of 2 pictures. See the yeah? And then the other one is, sorry, right there. Ralph, you get the first? I'll get it for you again. Ready? Let me get it a little bit big. There you go. Yes, this purple is squared. Well, no, because what am I multiplying by 1? I can multiply by 1 and not change anything. I can add 0 and not change anything. If I square something, I have to square root it to get rid of it. So I multiply by 1 using the conjugate because I know the radical is going to go away. I'm just going to get the inside minus the inside.
Oh, so you're trying to get it to a whole number.
Trying to get everything to cancel that doesn't have H in it. Right? That's your little secret. If you have things that have H in it, you have something wrong. You need everything to have a factor of H. Why? Because I need the H's to cancel. I need those H's to cancel. I'll be left over with some H in there, but that's okay because I have a value of H. What do you notice about the first slope? What did I need? I needed a x1, y1, x2, y2, right? So now if you need a good 2 shots here. All right, there's the first one. Get that one. Okay? Good. And then the second one. Right there. When I did the slope the first time, I did y2 minus y1 over x2 minus x1. When I did the slope the second time, all I needed to know was where was the first x and where was the second x. We're trying to make things quick. And we're doing that in prep for calculus. In prep for calculus. It seems like this is ridiculous amount of work right now, but I'm telling you, it'll make calculus easier. Next semester, I'm not teaching Calc 1, but I'm preparing you to take Calc 1 with even the most difficult teachers there is. Okay? So you don't have to worry about where the class is, when the class is. You'll be ready for any teacher. All right, I'm done today. I know what's up. Yes.
Which recordings?
Yes.
Or the names of the ones for
Yes.
last week
Yes.
and today's?
Yes. And so today's won't be ready for a while because I got to drive home, then open up my computer, and then it will generate. It won't do it when I'm driving.
Gotcha.
But today's recording is number 578.